My name is Angela Spencer, and this is my capstone project entitled Seattle-Everett Rail Corridor, Incorporating Resiliency. This capstone project was done in conjunction with the Masters of Infrastructure Planning and Management program at the University of Washington in Seattle, Washington, and it was completed in August of 2013. The introduction portion of the capstone project discusses the project area, and you can see it depicted in the map at the right. This map actually shows the entire Pacific Northwest Rail Corridor, and the area that is the subject of this capstone is the rail corridor that lies between Seattle and Everett in Washington State. This corridor has been designated one of the most high-risk rail corridors for landslides, and during our most recent winter between 2012 and 2013, we had one of the worst winters on record for landslide destruction along the corridor, with over 200 passenger and freight rail trips being delayed. Because this corridor is high risk, it requires resiliency in the form of hard and soft system tools. Hard system tools include early warning systems, weather monitoring stations, and geotechnical solutions. Soft system tools include community outreach, homeowner, and developer education classes. While the exact amount of economic damage due to these landslides was not made available, many projected that it was in the billions of dollars. Also examined were causes of the landslides. It was unclear whether these landslides were due to an increase in precipitation resulting from climate change, or if they were occurring due to new home development along the bluffs directly above the rail corridor and the associated removal of vegetation. It was projected that freight demand would almost double nationwide in the next 35 years, and incorporating resiliency measures into ongoing maintenance of the rail corridor and new projects along the rail corridor should stand to save rail stakeholders money and ensure rail efficiency in the long run. The literature review that was performed as part of this capstone examined contributing factors to the landslides and the rail stakeholders' response to the landslides. The UW's Climate Change Group released a report stating that climate change alone was not responsible for the landslides, and in fact it was a number of contributing factors. In addition, the USGS released a study in 1997 that looked at the landslides in the Pacific Northwest, and they discussed the fact that groundwater conditions, including the saturation of slopes due to successive rainfall, were a major contributing factor to these landslides. At the national level, the National Infrastructure Protection Plan's Freight Rail Modal Annex discussed the need for security, resiliency, and efficiency in the freight rail sector. The American Association of Railroads released a statement calling for security management and enhancing the capacity for rapid response and recovery. At the state level, WSDOT performed a qualitative vulnerability assessment of state-owned infrastructure, which this corridor is not. It's owned by the private company BNSF. But they found that landslides are a serious threat to the state of Washington due to an increase in, quote, extreme weather events. BNSF's documents were also examined. However, there were few to choose from. There was a study done for a different railway area, and while this study was not directly beneficial to this capstone in discussing alternatives and the landslides along the Seattle to Everett corridor, it was helpful in identifying the various rail stakeholders in the area. In addition, individual cities' ordinances and current tools being used to address landslides were evaluated. The methodology used in this capstone project was a mixed methodology. It had two components: a single descriptive case study and a systems analysis, which was helpful in showing the most effective methods for incorporating resiliency. The case study aspect of the project examined the location and dates and general history of the previous landslides in the area. It also examined the possible causes of the landslides. The systems analysis looked at, as described in previous slides, the various hard and soft system tools that could be employed to increase resiliency along the railway. The route definition employed for the systems analysis was as follows. Through a combination of soft and hard systems, rail partners, including BNSF, city, county, and state agencies, landowners, and land developers, can implement resiliency measures to address the increase in landslides along the Seattle-Everett rail corridor. Data that was examined for this project included publicly available reports and peer-reviewed published articles, as well as interviews that were conducted with members of BNSF, WSDOT, USGS, and most of the cities located along the rail corridor. Results and analysis for the Capstone project discussed landslide contributing factors and rail stakeholders' response. It was determined that several factors combined were causing the landslides, and that the increase in temperature and precipitation, as seen on several MET data charts contained in the project report, were not compelling enough to blame landslides completely on climate change. One of the most revealing discoveries in this project was the fact that water management issues, including broken pipes and the forcing of water into these slopes above the rail corridor due to the enforcement of low-impact development by the State Department of Ecology, and just management of stormwater in general, were causing or greatly contributing to these landslides. BNSF's response to these landslides was examined during interviews, and it was revealed that currently catchment basins, retaining walls, and slide fences were in place to deal with these landslides, and that in the future 6 locations would be improved along the corridor, 3 of which are already underway. And work in these areas would include the alteration of topography and the installation of weather stations, a hard systems tool, and increased work with the WSDOT mudslide group, which would be considered a soft system tool. This work is being funded by a $16 million grant awarded by the Federal Rail Association. Finally, public agencies, documents, and personnel were interviewed to determine tools that they were currently using and plan to use in the future to address these landslides. Many of them had critical area ordinances in place. Some had geotechnical aspects to their critical area ordinances, and some were planning on adding those. In addition, there was a WSDOT mudslide group that was increasing public outreach and education and increasing collaboration amongst the rail stakeholders. This slide gives a quick review of what Washington State has as their draft goals for the rail system going forward. The first column looks at the system policy goals. The second column outlines the freight and passenger rail focus areas for what will then go into the state rail plan, which is forthcoming. And the third column is my attempt to place these focus areas into hard and soft system applications. So you can see that economic vitality, preservation, mobility, environment, and stewardship all fall within the resiliency umbrella, and specific tools that were learned about through the interview process can be listed in this final column to show a direct application of these hard and soft system tools being considered at the state level. The major findings of the Capstone project were discussed in terms of which current and future resiliency tools should be implemented along the railway. And it was found that coordination amongst all the rail stakeholders was key in implementing these resiliency measures, and the incorporation of the hard and soft systems into the planning efforts was essential for long-term success of implementation of these measures. It was learned that BNSF, regional planning agencies, and small municipalities are currently educating themselves about efforts at all levels so that they can understand their role in liaising and understand what the other stakeholders are doing so they can complement those efforts. WSDOT's mudslide group, mentioned in previous slides, was examined, and it was determined that the collaborative efforts of this group, which included all the rail stakeholders along the corridor, were very positive and moving the application of resiliency in the right direction. At the local level, the individual homeowners and developers were learning more about critical area ordinances and were being encouraged to attend public outreach workshops. So cities were very active in implementing these ordinances and these public outreach workshops currently and in the future. It was also discovered that the federal grant funds for BNSF, WSDOT, and all the rail stakeholders in this area along the corridor showed a collaborative effort to increase resiliency and encouraged the stakeholders to work together. In addition, the discussion mentioned the fact that the word resiliency is not widely in use at this time. Other terms being used to describe resiliency in the industry included reliability, efficiency, cost effectiveness, risk management, and the strengthening of rail. The case study illuminated the landslide history, which in turn brought about the need for resiliency. It also identified a greater number of stakeholders and illustrated their roles in the process. The systems analysis looked at the hard and soft system tools that each of the entities were implementing. And it also looked at the fact that BNSF, being a private company, was incorporating mostly hard system resiliency tools as their privately owned company, and this was typical of that type of organization. In conclusion, there most definitely is a need for resiliency along the rail corridor. Rail and transportation in general is becoming increasingly susceptible to severe weather due to climate change and other factors, overdevelopment, and the mismanagement of surface water and stormwater runoff. Also, the solution to this problem is not BNSF's alone to solve. It requires collaboration with all local, regional, and state rail stakeholders. Finally, it was revealed that hard and soft system tools are best used in combination and across several jurisdictions for the most effective application of resiliency tools.